Lesson 2, Unit 1, Lesson 2. So if you're watching this video, you should have already done the model and discuss in your workbook on page 5 with a partner or in a small group. So you could go ahead and cross that item off. And now we're on to item number 2, which is the 1-2 video. So you can be following along right now, taking notes on pages 6 and 7. And then all of the things that you need to do on that checklist should look like this in Savvis. So make sure you're doing them on Savvis and copying them down into your workbook to be taking notes. And so our goal today is to create and solve linear equations with one variable. So remember, our variable is what we don't know. A lot of times it's x. It could be any other letter. Solving equations with just one variable. So maybe something like this. So this is what that model and discuss looks like. It's on page 5, so make sure you've already done it or go back and do it now. And today we're going to do examples 1, 2, and 4 together. I'm going to set up number 4 for you. We're going to skip numbers 3 and 5. So maybe don't cross them out completely. You might want to do them later for extra practice, but you could just X out the number to remind yourself it's not part of this video. And so I set my page up to look as much like your workbook as I could. And so on the left side, there's that blue space for any notes. You see I already have some notes there. So anything in that blue space is something you definitely want to write into your workbook. And so we're solving equations. So I wrote my inverses to remind myself I have my inverse operations. That is my best strategy for solving equations because they undo each other. So I have plus and minus, multiply, divide. Those operations undo each other. So my problem number 1 says, describe the steps of a solution of this long equation, right? That begins with the application of the addition property of equality, which was one of our vocab words. So if I set up my equation, I have 2 times x plus 4, all divided by 3, minus 8, equals 32. And I suggest you read out your equations like that too, naming all the operations that are happening, because that will help you decide what inverses need to happen. So I did a long line down through my equal sign to remind myself to do every operation to both sides of the equal sign. That is my property of equality, right? So I have to do everything to both sides. And so if I'm going to start with the addition property, that would probably be to undo some subtraction, right? Because that's the inverse. So I'm looking for some subtraction, and I see there's that minus 8 hanging out all by itself. So I'm going to do the opposite, the inverse, and I'm going to add 8. And I'm going to do it to both sides because I have to for the property of equality. And those cancel each other out because they're inverses. Minus 8 plus 8 is 0. So now I'm left with just 2x plus 4. All divided by 3 equals 32 plus 8, which is 40. So next, I have a lot of options every step of the way, but I'm going to maybe start with this divide by 3 because it's kind of trapping all those numbers above it. So the opposite of divide is multiply. So I can multiply that whole side by 3, but I don't even have to worry about that math because I'm doing it in order to cancel out. So I really don't have to worry about what it is. I just know I'm doing the opposite. They cancel out anyways. And now I'm left with 2x plus 4. And that's equal to 40 times 3, which is 120. 4 times 3 is 12 with that extra 0. So again, I have more than one option, but I have this multiply by 2 out in front. And so maybe I'll divide by 2 on both sides, because I'm trying to get x alone. I'm trying to isolate it. And so if the x and the 4 are multiplied by 2, I could undo that with division. So now I'm left with just x plus 4, and it's equal to 120 divided by 2, which is 60. And so last, I just have plus 4 over there with x, and I'm trying to get x isolated. So I'm going to subtract 4 from both sides, and that plus 4 with the minus 4 is 0. So now I'm left with just x. That was my goal, and it equals 60 minus 4, which is 56. Nice. So those are all the steps that we described. Maybe in your notes you could label the steps if that helps, or use an alternating color to remember. But right below that in your workbook, it looks a little different than my screen, but it does ask you how can you check that a value of the variable makes the equation true. So they want us to check our solution. So if we're going to check that the number we got is correct, which was x equals 56, we're going to write out our equation, our original equation, but we're not going to include x. We're going to leave the x out. So you see I did a little space to show you where x was. And so now I'm going to fill that space with what number we found for x, which was 56, right? And so we're going to evaluate now and see, does it actually equal 32 like it's supposed to? And so when we evaluate, we're going to do that in the order of PEMDAS. So we're going to start with our parentheses. We have 56 plus 4, which is 60. So now I have 2 times 60 divided by 3 minus 8 equals 32. Next is m. I don't have any exponents, so now is m, and I am multiplying 2 times 60, so next I'm going to do that. 2 times 60 is 120, divided by 3 minus 8 equals 32. I just keep copying down my entire equation. So now I'm going to snake up to the top because I'm running out of room. But I do have D, division, 120 divided by 3. So that's what I should do next. 120 divided by 3 is 40. Minus 8 equals 32. And 40 minus 8 is 32. So it did actually equal what it was supposed to. And so I know my solution is correct. So always be checking your answers. And then maybe also review that vocabulary on the bottom of my screen that's not on your workbook. But remember that a variable is what we don't know. And then our solution is a value for that variable that makes the equation true. And that's what we're looking for throughout this whole unit. So we're going to move on to example number 2. Make sure you're done with 1. Example number 2, I already have, again, some notes, some vocab in there. The question asks the sum of 3 consecutive odd integers is 57. So what are those integers? The question is important because that's going to tell me what my variable is going to be. But first, let's remember that sum means we're adding. And consecutive just means that they're in a row, 3 in a row. And so an example maybe of 3 consecutive odd integers would be like 3, 5, and 7. They're odd, they're not even. Odd numbers, they go up by 2, so I'm adding 2, adding 2. But those don't add up to 57, right? So let's map out our problem. I have 3 numbers, and we're going to add them together because it said sum, and it's going to equal 57. And so I want to assign my variable, right? The question was, what are the 3 integers? So I want to assign my variable. We could use x again to those integers. I can't do x plus y plus z, even though there's 3 different unknowns, because then I can't solve for x. So if I call the first integer x, I can name my second integer using that because I know something about it, and that is, like with our example, my next integer should be 2 more than the last. So I can call it x plus 2. And then my next integer will be x plus 2 again. So that would be x plus 4. So now I have my equation only using x, so I can actually solve for x. And let's clean it up a little bit so we can solve for x. So I have some like terms. I can combine them. They all have the same variable. So 1x plus 1x plus 1x is 3x. And then I also have some like terms with my constants. I have a plus 2 and a plus 4 that have no variables. So plus 2 and plus 4 is plus 6, and that's going to be equal to 57. So again, I'm going to set up my equation to solve with my line through the equal sign to remind myself to do everything to both sides. So if I'm trying to isolate my x's, I'm going to first get rid of this plus 6 over here with a minus 6, so that those will cancel each other out. And now I'll have 3x equals 57 minus 6 is 51. And so if I have 3 times x, the opposite of multiply is divide. So I'm going to divide by 3 on both sides. 3x divided by 3 is just 1x. And that's equal to 51 divided by 3, which is 17. But I'm not quite done yet, because just before we move on, let's look back up at our question. It didn't ask to solve for x, it asked what are the 3 integers. So my answer should be 3 numbers. So if x was supposed to be my first integer, I'm going to do the 3 consecutive odd integers, 17, 19, 21. X plus 2, and x plus 4. And now I'm all done. So one more problem left. We have example number 4. I'm just going to set up the equation with you guys, and then you're going to try to solve for x. So our problem says 4 friends buy tickets for 2 shows on consecutive nights. Remember, consecutive means 2 in a row. They use a coupon for $5. So if I see a number, maybe I'll highlight that. $5 off each ticket. They pay a total of $264 for 8 tickets. So write and solve an equation to find the original price. So that's what we're looking for. That's my unknown. So that's probably going to be my x. And so what I know is that whatever we have, the total is 264. So that's some good information. It's all going to be equal to 264. And I have 8 tickets. And how much did they cost? They cost X. We don't know the original price. But we do know that they got $5 off. So X minus 5. If they got $5 off, we're going to take away 5. But we didn't just buy 1, right? We bought 8 of them. So we could add that up 8 times, or if I could just multiply X minus 5 by 8. So I have X minus 5 8 times, and that's going to be equal to 264. So go ahead and set your equation up to solve and look for X.